Okay, now coming to the next concept, it is very important concept. So that is left recursion. First of all, we have to know what is the left recursion. If a grammar or production, okay, if a rule in the grammar, if a production in the grammar is of type A tends to A alpha or beta, which means the leftmost symbol in the RHS is equal to the LHS. It means, for example, okay, you take this example. See here, this is the LHS, this is the RHS. So this and this, okay, both are same. Then what you say, the grammar is in the, so in the left recursion. It is a left recursive grammar. That is what. Okay. So if I have a left recursion, then it will be like this. So for example, so I'm having a grammar A tends to A alpha or beta. A tends to A alpha or beta. Now what I am doing, so I am generating a tree here. First I write A equal to A alpha. Again I am writing in the place of A alpha. Again in the place of I am writing A alpha. Finally what I am writing in the place of I am writing B beta. Okay, so then what will be happen? So which is equal to, it is beta alpha star, nothing but a, so beta alpha star. Okay, it means what is the language? So beta alpha star. So what is star means what? Number of alphas, 1 2 3. So star equal to 3. So then I'm getting the 3 alphas. So what is the problem? Generally if a grammar is in the left recursion, so there is a chance to enter into infinite loop. Okay, then we have to avoid that. That is a problem. Okay, so then we have to avoid that. So very simple. What is the left recursion? Now you see here, so this symbol and this both are same. Then what you say, the grammar is in the left recursion, so we have to avoid that. Then how to avoid? Very simple. So you update this grammar as like this. Okay, so A tends to beta A dash tends to alpha A dash or epsilon. So I will take one example how I am getting this one. So what I am writing here, this is what. Okay, A tends to A alpha, again A alpha. Then what I am writing in the place of A, I am writing beta. Okay, then it means what? So now you see this. So I am writing this as, which is equal to A tends to beta A dash. What is A dash? A dash equal to, so alpha A dash. Okay, so what is alpha? So this is, okay, so alpha A dash or epsilon. Okay, so for example, I am replacing in the place of A dash. If I write like this, what will happen? So A dash tends to beta. In the place of A dash, I am writing alpha A dash. Alpha A dash. Okay, now again what I write? Okay, I want to get one more alpha. So it means, so A dash tends to beta alpha. Again in the place of A dash, I am writing alpha A dash. Alpha A dash. Then again A tends to beta alpha alpha. In the place of A dash, I am writing epsilon. So which it is going to disappear. So that is what. Okay, so then beta alpha alpha. So A tends to beta alpha alpha. Okay, even though without using this I am getting beta alpha alpha. So when I update like this, I am getting the beta alpha alpha. Okay, and this is going to vanish. Okay, so finally, so A tends to beta alpha alpha. So very simple. So if you this is the way how I am writing this formula. Okay, so A tends to A alpha, A tends to beta. So this is the grammar in the left recursion. Okay, so then you have to update this grammar into like this. Now see here in this I don't have any left recursion. Okay, so this formula you have to apply for the for the problems. So how I got is, this is the way how I got. Okay, so beta alpha a dash. So in the place of a dash, what I am writing? I am writing the alpha a dash. Okay, like this. Now you see here. So for example here, t tends to t star f f. So now you see, this is the grammar in the left recursion. Then you have to apply this formula. A tends to a alpha beta. Now what is a? A equal to t. What is alpha? Alpha equal to star f. Alpha equal to star f. So beta equal to what? Beta equal to f. That is what. Now, so this is the alpha, this is the beta. Okay, now you apply this formula for this one. Okay, so what is a here? So t tends to beta equal to what? F. What is a dash? T dash. Now what is a dash? T dash tends to what is alpha? Alpha equal to star f. Okay, alpha equal to star f. Okay, alpha equal to star f t dash, finally epsilon. Okay, this is the answer. Okay, now you see here, so this symbol and this, they are different. Okay, so here also these are different. Now this is the grammar without having any left recursion. Okay, so this is the answer. Now take one more example here. Take one more example. So A tends to A, B, D, R, A. Eliminate left recursion. Now you write here A tends to A, B, D, R, A. So you apply the same formula here. Okay. A tends to A alpha or beta. Okay, A equal to, simply I'm comparing the formula. So what is alpha? Alpha equal to B, D. What is beta? Beta equal to small a. Beta equal to small a. Then you have to apply the formula. What is the formula? A tends to beta a dash. So A tends to, what is a B? What is a beta? Beta equal to A. A, A dash. Okay. Then what is A dash? A dash equal to, A dash tends to, what is alpha? Alpha equal to B, D, K dash. So R epsilon. Okay, so this is the answer. So in this way you have to eliminate the left recursion. Okay, this is the answer. Okay, now you see here, in this I don't have any left recursion. Simply what I am doing, simply I am applying the left recursion only. Simply I am applying a formula. Okay, so this is actually grammar having a left recursion. I am updating the, I am getting a this formula using what? So using like this. So A tends to A alpha, A alpha. So B I am writing here. So B A dash. What is A dash? A dash equal to what? So A dash equal to alpha A dash and then epsilon. Okay, so this is the formula I am getting by using this tree. Okay, so even the language is same as using this grammar. So the language is same as using this grammar. There is no change in the language. Okay, so in this way you have to eliminate the left recursion. simply they will ask for 2 marks, so they will give one grammar. Simply you have to make some comparison. A tends to A alpha or beta. This is A, this is the alpha, this is beta. You apply this formula, okay, you'll get this answer. Okay, so that is all about the left recursion. Now next one. So simplification of context free grammar. Okay, it means what is simplification of a context free grammar? It means you have to eliminate the unit productions. Okay, you have to remove the uh, unit productions. You have to remove or eliminate the null productions. You have to remove the useless symbols. Okay, so I'll take example. First of all, so how to eliminate unit productions? If a production is of the form A tends to B of the form, okay, it means, okay, now you see here what they are saying. So A tends to B. This is a what? Non-terminal. This is a what? Non-terminal. Okay, it means I am going to generating the tree continuously. There is no any ending here. Okay, see count equal to how much? 1. So count equal to how much? It is 1. So LHS equal to 1 variable, RHS equal to 1 variable. Okay, at that time what you have to do? You have to eliminate, okay, these type of productions. Why? Because these type of productions may enter into the infinite loop. Okay, very simple. Now you see here, so this is the grammar. Okay, so S tends to A, B or BC, A tends to B or CA, B tends to S or AB. Okay, first I'm writing separating the, so without unit productions. So S tends to BC, A tends to CA, so B tends to AB. Okay, now you write here. So S tends to A tends to B, B tends to S. Okay, now what you write? You write all possibilities. Okay, how to remove the unit productions? So now what is A actually? A equal to what? A equal to B. B equal to, sorry, A equal to, it is CA. So I have one more option, one more possibility. What is one more possibility? So AB. Okay, so then you write, so S tends to, so A. Okay, now what is A? S tends to A equal to what? It is CA. This is one possibility. Then you add the CA here. So in the place of A, what you write? So A derives B. So then S tends to B. Okay. So what is B equal to? It is AB. Then S tends to AB. So S tends to AB. So you write all possibilities. So why? Because so S derives A, indirectly A derives B. So write CA and then AB. So in this way you have to remove the unit productions. This. So when you remove these productions, I am getting these two rules. Okay. Now take one more thing. Next one, what? A tends to B. What is B actually? A tends to B means what? It is AB. You write AB here. So actually what is B? B means what? B equal to S. It means B derives S. So A tends to S. A tends to, what is S? S equal to what? S equal to BC. So you write BC. Then you write BC also in the answer. Okay. Now next one, what? B tends to S. So B tends to S. So S equal to what? S tends to A. So B tends to, one second. But before that, what is S equal to? S equal to, it is BC. You write BC in the answer. So now what is S? S tends to the A. So what is A? B tends to A equal to what? A equal to CA. CA. You write in the answer as CA. So this is the answer. Okay. So now you see here in this grammar, I don't have any unit productions. So S tends to BC or CA or BAB. A tends to CA or AB or BC. B tends to AB or BC or CA. Okay. So by observation, I don't have any unit productions. Okay. This is the grammar. Now take one more example. So you see here in this grammar, I don't have any unit productions. Here I don't have any unit productions. I don't have any unit productions. Now where I am having, here I am having. Okay. So S tends to A. Then S tends to A. Now what is A actually? S tends to, you write all possibilities. What is A equal to? A equal to CAD. Or what is one more possibility? It is CD. Okay. Then finally what is the answer? So S tends to A is D. So you remove this production. So instead of this, I am getting these two. So you have to add this to the answer also. Then A tends to CAD, A tends to CD. Okay. So this is grammar. Okay. Now you see here in this production. Okay, you don't write this in the answer. So what is the answer? This is the answer. So there is no any unit productions. Okay. So here length equal to how much? 1. Length equal to 3. Length equal to 2. Length equal to 1. Length equal to 3. Length means what? Like this you write tends to A S D. Length equal to 1. Length equal to 3. That is what. So this is about the how to remove the how to eliminate unit productions. Okay. Now next one. So how to eliminate second one what? So eliminating the null productions. So it means what? In a grammar, okay, in a grammar, if I am having the rules of the form A tends to epsilon, then we have to remove this. Very simple. How to remove? Simply you replace there. Okay. So write the answer. A tends to B C Z. Now in the place of B, you replace epsilon. Then okay, this will be the answer. One A tends to epsilon C Z. Then what is the answer? A tends to C Z. Okay. Now again what? In the place of okay, in the place of C, what you write? You have to place the epsilon. Okay, you have to write epsilon. Then what will the answer? So this is one answer. Okay. So I explain A tends to, in the place of C, I am placing epsilon. Epsilon. Okay. Z. So Z means what? So A tends to, so Z. Okay. So this will be the answer. Okay. Now finally, okay, I am doing one thing. So I'm replacing, I'm writing a one production Z tends to small a. Why? Because I'm getting a unit production here. That is what. Okay. So now what is the answer I'm having here? So in the place of B, I'm writing the I'm writing the answer separately. What will be the answer? So A tends to B C Z. This will be one answer. Second one what? When you replace in the place of B, what is the answer? A tends to uh, CZ. Okay. Again what? In the place of C, what I'm replacing? I'm replacing epsilon. What will be the answer? So Z. We have to eliminate this. Then what will be the answer? A tends to small a. Why? Because Z equal to A. Again A tends to, now B, in the place of C you write epsilon. Okay. Epsilon Z. What will be the answer? So A tends to, so BZ. So this also you add to the answer. A tends to the BZ. Again what? In the place of B you write epsilon. Already we got. Okay. then what will happen? A tends to epsilon z, A tends to z, so it is already there. Okay, so this is how to remove the, how to eliminate the null productions. Now you see here, in this grammar I don't have any null productions. See, you write all possibilities, that is what. Okay, you have to write all possibilities. Okay, we'll take one more example. Now you see here, so S tends to AB AC, A tends to AA R null, B tends to BB R null, C tends to C. Okay, eliminate null productions. So first to write the without null productions. 8 S tends to AB AC. So next A tends to small a, capital A, B tends to small b, capital B, C tends to small c. Okay, these are the productions which don't have the null productions. Okay, now you write A tends to epsilon, B tends to epsilon. Now you, what you do, you replace wherever A, write all possibilities. Okay, first I am writing A tends to A, A, A tends to, in the place of A I am writing epsilon. This will be the answer. Now, okay, now you take this production. S tends to AB, AC. So here I am writing epsilon. S tends to epsilon BAC. What will be the answer? S tends to BAC. So actually this you have to write above, I am writing below. So S tends to BAC. Again you replace, in the place of A you write epsilon. S tends to B epsilon C. So then S tends to BC will be the answer. Okay, S tends to BC. Okay, now again in the place of B you write epsilon C. S tends to C. C equal to what? It is small c. So then S tends to small c. Why? Because this is the unit production that you have to eliminate. So that is one possibility. Take one more possibilities. S tends to AB AC. Now in the place of B I am writing, okay, in the place of B I am writing epsilon. So S tends to A epsilon A C. Okay, then what will happen? So S tends to A C. So then S tends to A C. Okay, now there is one more thing here is, so this will be there also, this is also there. What is that? So B tends to BB, you write epsilon in the place of B epsilon. What will be the answer? B tends to B, B tends to B. Okay, now again what you write, in the place of A you write epsilon. S tends to epsilon AC, then S tends to AC. It is already there. No. Okay, you have to add that also. S tends to AC. Then finally, so in the place of A, you write S tends to epsilon C. What will be the answer? S tends to capital C. In the place of capital C, you write a small c. Already it is added in the grammar. Okay. So like this, you have to write all possibilities. Okay. So maybe I may be missed. Okay, you check it once. So this is the how to eliminate the null productions. You write all possibilities. See, first I write in the place of A. This is the grammar, I mean rule. So next I write here. So I got BC. Next I write like this. I got S tends to small c. Next in the place of B I write, okay, I got this rule. Next in the place of this I write epsilon, I got this. Okay, so finally, okay, this will be the grammar. Okay, so in this way you have to eliminate the null productions. This is called simplification of a context free grammar. So finally what, so how to remove useless symbols. Okay, so how to remove useless symbols. Now you see here, a symbol can be useless if it does not appear on the right hand side of a production and it does not take part in the derivation of any string. That symbol is useless symbol. Now you see here, I am taking an example. So T tends to small a b a a t. A tends to a capital A. So B tends to a b or small b. C tends to a d. See what they are saying. By observation, symbol means nothing but a non-terminal. So the capital C is not appearing anywhere in the right hand side. So C is the useless symbol. Okay, C is the useless symbol. That is what. Okay, next one what? So now you see A tends to A also useless. Why? Because see it is not deriving any string. Okay, it is not deriving any string. It means what? So for example, what is deriving? Okay, so you take capital B. So T tends to small a capital B. So what is capital B? I am getting some terminal is there. There is a terminal is there, nothing but a, there is a ending of the string is there. Okay, so a b. So in this string I don't have any non-terminal, it is completely terminals. So in this way I have to get, then what will again, so a also useless. Okay, see for example what it is saying is, for example if I take T tends to a b a, in the place of a you take one more time. Okay, a b a a, again in the place of a b, in the place of a again you take a. See again I am getting the non-terminal, there is no ending for the string. So we have to get some string, that is what. So then what you say, so C is a useless, so A is a useless. Why C is a useless? Because it is not appearing anywhere in the right hand side. Why A is a also useless? Because A is not generating any string like this. See by observation here, see it is, for example you take one more time A B A, in the place of a again I have to take a, there is no ending for the a, it is generating completely. That is what a also useless symbol. Finally what you say, so in this grammar, so T tends to aab aat. Okay, so B tends to ab rb. So these are the useful non-terminals, that is what useful symbols. Okay, now take one more example here. So you don't get confused here. So for example C is not appearing, you remove that directly. Again what, the A is appearing at the right hand side, but what is the problem? It is not generating any string. It is again and again I'm getting capital A, there is no ending. Okay, that is the problem. Now take one more example. So S tends to AZ SY XA, X tends to BSZA, Y tends to ASY BYZ, Z tends to AYZAD, A tends to ABRAA. Now first of all, can you tell what are the symbols which are not appearing on the right hand side? Okay, it means X is appearing, Y is appearing, X is appearing, Y is appearing, Z is appearing. Now we have to focus on which is not generating any strings. Okay, so by observation see here, X tends to B S, okay, Z A, it is not getting any string here. So for the Y also, okay, see Y also I am not getting any string, A S Y B Y Z. Okay, now you see here this also I am not getting any string here. Okay, for the even for the A also, so even for the A also, here I am getting a string, but what about here? Again it is generating the, it is not generating a string, it is continuously getting. Okay, I mean one second. Okay, it is getting continuously a like this. Okay, then Okay, then what you have to, okay, then one second, there is a problem. So actually x is not rich, I mean x is not generating, you remove this. Okay, so y is it is not generating any you remove this. So because I am removing x, you have to remove this also. Okay, you have to remove okay, you have to remove. Okay, so this one is removed, so 1 2 this one. Then what will be the grammar? S tends to a z. Okay, then s y. So this also you have to remove. Why? Because I have removed the y. So then again what? So x is removed, y is removed, so z tends to, so this you have to remove. Why? Because it is not generating, so z tends to ad. Finally what will be the grammar? So then s tends to az, z tends to ad. So these are only the useful symbols. Okay, so actually a is generating a string, but why? Because it is attaching to the x. So we are removing, we have removed this one. So then what will happen? A is not appearing on RHS. That is the problem. Okay, so then finally s tends to a, z tends to ad. So these are only the useful non-terminals in the grammar. Okay, first of all what? These two are not generating any strings. Okay, that is one thing. So because x is attaching to the a, we have removed this. So finally what? So a also removed, even though it is generating the strings, it is removed. Okay, so finally what? S tends to a, z tends to ab. Okay, so in this way you have to remove the, in this way you have to remove the useless symbols. So what is the, what is simplification of a context free grammar? So it means what? What is simplification of a context free grammar? So three things you have to note. One is what? You have to eliminate unit productions, you have to eliminate null productions, you have to remove useless symbols. Okay, next we'll discuss about the normal forms in the theory of computation. So we are having a two normal forms. One is Chomsky normal form, second one is the Grayback normal form. Okay.